today's lesson, if the oxidizing agent and reducing agent are both in the same molecule. The first 5 steps for balancing redox equations using the oxidation numbers are the same for basic solutions. Begin by assigning the oxidation numbers for every single atom in the reaction. For step 2, you must identify which atoms are losing and gaining electrons by seeing which ones have a change in oxidation number. For step 3, determine how many electrons are transferred for each molecule or ion. As before, you should be able to determine which entities are reduced and oxidized by observing the oxidation numbers. Step 4 is also the same as in acidic solutions. We need to balance the electron transfer by multiplying. The number that we multiply by becomes the coefficient. In step 5, we must add water to balance oxygens and hydrogen ions to balance the hydrogen atoms. Steps 6 and 7 are unique to basic solutions. In step 6, we need to add hydroxide ions to each side of the equation. We need to add the same number of hydroxide ions as there are hydrogen ions in the reaction. In step 7, we need to combine any hydrogen ions and hydroxide ions to create water molecules. We will also need to cancel out any water molecules if they are remaining on both the reactant and product sides. Once the waters are canceled, you will have your balanced equation. Disproportionation reactions are what we call a reaction when a single substance is both oxidized and reduced. It is very helpful in these types of reactions to start with 2 identical entities on the reactant side and then follow the usual procedure for balancing. Here we determine that hypochlorite ions are both the oxidizing agent and the reducing agent by assigning oxidation numbers. We can simplify the problem by writing the hypochlorite ion twice. We will be able to balance everything out through the process that we are following, so it is okay that we are doubling the amount of this ion. From this step on, we can follow the steps as normal. One hypochlorite has a 2-electron transfer and one has a 4-electron transfer. For this reason, we must double the first hypochlorite by adding a coefficient of 2 in front of hypochlorite and the product that it corresponds to. Following this step, we would go on to balance the oxygens and hydrogens as required. Please complete the October 4th quiz.